Good morning, students. So the last class we discussed about the topic is what is the angular velocity and angular acceleration and torque. Okay. So now discuss today about the topic is so the derived expression for final velocity. Derive the expression for final velocity and total energy of the body rolling without slipping. Okay, without slipping. So expression for final velocity and total energy of a body. So rolling without slipping. So now here taken, so consider the body. So that is the rolling body. Okay, so of mass m and radius r. Okay, now here see that. So that is the body of rolling body that taken capital mass m. Okay, and radius is taken r. Is a rolling without slipping. Okay, is rolling without slipping. And so to reach the border and with height is taken h. Okay, and so the body is rolling some velocity, that is vb, the velocity of the body is taken. Okay, so now consider the body of mass m and radius r without slipping. Okay, so without slipping is to reach the bottom. Okay, and so the taken height is h. Okay, so the taken height is h with velocity is v moving. Got it? Now consider or assuming the body of mass m and radius r is to reach the bottom without slipping and some velocity is v and height is taken h to the surface. So now here the rolling body consists of two translation, or that is the translation kinetic energy plus rotational kinetic energy. Okay, the rolling body will having, okay, so the rolling body will have one is translation kinetic energy. Okay, so the translation kinetic energy plus also similar pattern here observe, that is also rotational. Okay, translation is one taken and rotational another taken. So that is called as a rotational kinetic energy is equal total energy of the rolling body. Total energy of the rolling body is equal to translation kinetic energy plus rotational kinetic energy is called total energy of the rolling body without slipping on inclining plane. Okay, now so right is taken, so the equation, so the kinetic energy to the translation and kinetic energy rotational. So the translation, already we know the translation kinetic energy is taken E is equal of mv square. Okay, right. So that is the E is equal. E is nothing but total energy of the rolling body is equal to translation kinetic energy. Translation kinetic energy of mv square. Now, so what is the rotational kinetic energy? Okay, so rotational kinetic energy of I omega square. Here translation is taken m, but in rotational is moment of inertia. I means moment of inertia. Omega means angular velocity. Okay, already so discussed that topic angular velocity. So here taken the translation velocity is v and rotation is taken omega. So the translation kinetic energy of mv square. Okay, rotational kinetic energy of I omega square. Okay, got it. Now here already so the V is equal R omega derivation. Okay, V is equal R omega. So V is equal R omega. So omega is equal V by R is taken. Now omega square is equal to V square by R square. V square by R square. And also K is equal to under root of I by M. So K is called as a gyration. Okay, so gyration of the body or gyration of the disc, so gyration of the metal. So what are may be taken? So the K is equal under root of I by M. I means moment of inertia. Okay, I by M. So I by M, so that means both sides square taken. So the K square is equal I by M and I is equal to K square M. Okay, K square M taken. So omega square is equal and I is equal. These two equations are substituting in the total energy equation. So E is equal to R M V square. Okay, plus of I means so K square. So K square M is taken. And what is the omega square? Omega square is equal to V square by R square. Okay, now taken the common term. So E is equal of M V square. So remaining 1 plus. Now we have taken M V square of is taken common. Okay, so remaining equation. So K square by R square. Okay, K square by R square. So this is called as a total energy of the rolling body. Okay, total energy of the rolling body without slipping. Also to find out the final velocity. Okay, also to find out the final velocity of the body. So final velocity of the body is taken. So now here complete clear observe that. So the body is okay. So that is the first of all potential energy. Okay. So the body will having potential energy now first, and so it is moved to reach the ground. Okay. That is the potential energy is losses and kinetic energy is gain. Okay. Potential energy is loss is equal kinetic energy is gain. Okay. So the potential energy is equal to okay, potential energy is equal to kinetic energy. Okay, at any point is taken, A is equal or taken B point is taken or A is equal to B. That is means potential energy is equal to kinetic energy according to law of conservation of energy. Okay, so based on principle of law of conservation of energy, potential energy is losses. Kinetic energy is gain. That means potential energy at any point is taken kinetic energy or total energy. Now, so the potential energy at a point A is taken mgh. Okay, potential energy is taken mgh. That is equal kinetic energy. So the kinetic energy already to find out the so E is equal. Okay, E is equal of mv square into 1 plus K square by R square. Okay, K square by R square. Now to find out the final velocity. Okay, so final velocity means V. So M R cancel. M and M R cancel. So remaining equation we can write. So V square is equal. Okay, V square is equal 2 into 2GH. 2GH by 1 plus K square by R square. 1 plus K square by R square. Okay. Now V is equal under root of 2GH by 1 plus K square by R square is the final velocity of the rolling body. Okay. Final velocity of the rolling body. So, final velocity, how to find out the final velocity? So, the potential energy is the losses to gain the kinetic energy. Okay, so that is equal potential energy at a point A is equal kinetic energy at a point B. So that is equal mgh is equal total kinetic energy of mg square 1 plus k square by r square. K means gyration. Okay, got it? So v square mmr cancel. Now find out the final velocity. Final velocity is v square. So v square is equal to 2gh by 1 plus k square by r square. So v is equal under root of 2gh by 1 plus k square by r square. Okay, got it? Right. So now discuss the another topic is so law of conservation of or law of angular momentum. Okay, so law of conservation of angular momentum. Angular momentum. Okay, so law of conservation of angular momentum. So the statement of the law of conservation of angular momentum. Okay, so there is no external torque is acting on a rolling body. Okay, so the no external torque is acting on a body, on a rolling body, or there is a rotating body. Thus angular momentum of the system. Angular momentum of the system is remains constant. Angular momentum of the system remains constant. So once again repeat, there is no external torque. There is no external torque of force is acting on the system. The angular momentum of the system is remains constant. Angular momentum of the system remains constant. That means L is equal constant. L is equal constant. Okay, that means I omega L is equal I1 omega 1 or I omega is equal constant, or I1 omega 1 is equal I2 omega 2. I2 omega 1 is equal I2 omega 2. Angular momentum. So there is no external torque acting on a rolling body or rotational body. Okay, so the angular momentum of the system remains constant. So that means L is equal constant or I omega is equal constant. In other words, I1 omega 1 is equal I2 omega 2, that is equal also constant. Now is taken proof. Okay. So that is nothing but now resultant external torque is acting on a body. Resultant external torque acting on a body, okay, is equal to the angular momentum. Okay, angular momentum. So change in the angular momentum. So tau is equal dl by dt. So according to the definition, tau is equal d by dt. So L is equal I omega. I means moment of inertia. Omega means angular velocity. And substituting in the equation I omega. Okay, d I omega by dt. Okay, so next here taken according to the definition, if tau is equal 0, there is no external torque. There is no external torque acting on the body. So that means d by d theta I omega is equal, okay, 0. Okay, so in another words, is taken I omega is equal constant. I omega is equal constant, or I1 omega 1 is equal I2 omega 2, that is equal constant. Okay, got it. According to law of conservation of angular momentum. Okay, according to law of conservation of angular momentum. So that is means there is no external torque is acting on a rolling body or rotational body. There is no external torque. That means angular momentum is remains constant. Angular momentum is constant. Okay, got it. So according to definition, we can write the tau is equal dl by dt. But L is equal, what do you mean? L is equal I omega. L is equal I omega. So substituting in the equation, so we can write if tau is equal 0, d by dt I omega is equal 0. So I omega is equal constant. So I1 omega 1 is equal I2 omega 2 is equal constant. Okay, got it. So now discuss the another topic, another chapter in a next class. Okay, thank you students.